So they gave us. That's a class, right? Yeah, it's a class.
Hey, can you guys check the officers channel? See if the link works on Zoom.
Oh, no. I can't be. Yeah, the office.
Hold on. I'm deactivating it.
Hello.
Okay. So one more person try. I'll send the link.
Hi.
Hi.
Hello, my beloved. Awesome.
Homie, that is not the stand-up slides. Brother.
Jacob, can you hear me right now?
Yeah, that's not the stand-up slides, bro.
Yeah, I'm trying to get them projected. Taking around 3 years. I really should. Hold on, give me 1 second. Hold on, it should be ready. What's happening? Okay, let's try Ethernet. Perfect. Okay. Cool. Well, welcome. Hey. Okay, whatever. First off, welcome everybody. Welcome to our first official stand-up at Purdue. There's been a lot that has gone on this past month, but I'm glad you guys have kept working. We'll just be doing a quick rundown of the projects just first. Can you guys take a minute just to open your phones and log in? Just so we can mark attendance. Yeah, I know. But how is Jacob gonna know? You came here looking so cute and so ready to work. I'll give it another minute or something. Cool. Everyone got the link? Anybody not get the link? All right, let's roll. Let's start with the first team, which is going to be chatbots. I know it's been very popular. Sagar, if you want to come up,
Yeah.
get it rolling.
We had our first meeting yesterday. Unfortunately, I had to. Oh, there's a mic.
Yes, my computer.
Okay. So yeah, we had our first meeting yesterday. Not a lot of people showed up in person because I had to reschedule it, but there were a bunch of people online. Unfortunately, the Zoom ended at 40 minutes in because that's how we get with the free version. But yeah, so about our project, so we are pursuing like two separate, somewhat related projects right now. One of them is making a Python library that that can be used for building out sampling techniques on transformer-based language models, and the other one is using a transformer-based language model to sample in conjunction with like a Python language server in order to generate API calls from text commands.
Yeah. Oh, I'm so sorry. That is a huge oversight. Okay. Probably.
All right, no, what everyone. It's okay.
Okay. Well, thank you. Fingers.
Also, make sure that you monitor for people in the weight room, or you can make me
I disabled it.
a moderator. Okay, gotcha.
I can check, but I think it's just us. Okay, cool. Back to it.
Okay, so yeah, that's the summary of the project. And last meeting yesterday, we got a few steps done. I was able to introduce everyone to the project and what we need to work towards. And we sort of set the pathways for future work. We got some, I had some initial brainstorming that I wanted to present, so we got everyone familiar with that. And if you didn't attend the meeting, if anyone here is on the team, and you didn't attend the meeting yesterday, don't worry too much about it. You'll get caught up quickly. Also, definitely keep up with the Discord. So yeah, we introduced the pathways for future work, and that was last meeting. Hurdles. Yeah, I accidentally scheduled it on the wrong day when I wasn't here, and also turns out Zoom only stays up for 40 minutes. And also no one wants to work on prompting, which is a bit unfortunate. That's a third project we wanted to work towards, and
You don't want to make a prompt engineer by?
so
Can I just use Purdue?
I didn't know that existed.
If you use your Purdue email under Zoom, you get a free like program.
Yeah, I kind of realized that afterwards.
It's okay. I made that mistake for the actual launch, so could be worse.
So next steps is actually like getting tasks delegated so that everyone can start working on something. Those 2 points mean the same thing. I just realized that, but yeah, so I'll get all that set up by the next meeting, and hopefully everyone will have something to work on. Until then, it's just mostly just getting familiar with transformers and doing the little collab notebook that I posted on the Discord.
Cool.
Yep.
Ready to go? Okay. Nick, you want to come up with Vex?
So we're making a computer vision model to detect goals, and if anyone's ever played like frisbee golf, their frisbee golf goals are just basically baskets with chains around them. And then we're also planning on generalizing that model to be able to work on, because we have to write a lot of hardware code for the robots that they go on, which are Vex robots that the SIGBOTS group at Purdue create. So we're working on also creating just like a general computer vision model that you can just input whenever you put in whatever weights you want, and then whatever camera system you want, that'll work with any of the Vex hardware and work with any of those robots. So we're planning on releasing that to the Vex community, because Purdue has a pretty big influence on that community. So what we've done in the past few weeks is we finally have a working model that is resistant to vibrations and has pretty good accuracy for right now. But it only has good accuracy in one setting, so all our photos are from one particular lighting setting in one room. So that's on the next slide, but more stuff we got to do. We have the labeled data set. It's about 1,000 images right now. Some of them are with both iPhone cameras, some of them are with a DSLR camera. And then we were using Intel RealSense cameras before, but those are big and clunky, and also they don't have really good they don't have any good like packages behind them to work on just any computer. They basically they work best on Windows computers, and Linux, they're like Intel, or like it's called Pi RealSense to work with Python. It sucks, and we couldn't really get it to work that well. So we switched over to these Oak One cameras that are pretty good, and they have their own onboard computers that will do any AI computation. And so right now we're testing the difference between that, just doing the onboard processing, and then or putting the data onto a NVIDIA Jetson and testing if that's faster. But we would have to pull from the camera to the Jetson and back to the robot brain. So that's kind of a big thing, is latency. I don't know, will this play? It will not. Okay.
Yeah, you want to show it? I can just.
No, it's literally just the model. It's just like putting a bounding box around a goal.
Cool. And let's see if we can click still.
There we go.
Okay, hold on one second. Yeah. It'll work. It'll work. Just be patient. Tell it nice things.
There we go. All right. So our issues right now that we're trying to work on is, like I said, getting high accuracy on a device with high vibrations, because it's mounted onto a robot that is moving around very quickly. there's a lot of vibration, so just getting the cameras stable, which are partly on the camera system itself, because we had some Oak cameras that came in and they vibrated a lot and they were not very good. And then we had other ones that were the same model, it's just however they came off the production line. Some of them handled vibrations better than others, so a little bit of it's hardware. Another thing we're working on is getting a larger and better data set, because right now our data set kind of sucks. It's not that big, and like I said, it's all one setting, one lighting. Latency is a huge thing because it'll be on live robots that are trying to play a game, and the whole point of being able to detect the goals for the game is so that we can have the robot. The robot has like a turret on top that shoots little discs, the frisbee discs into the frisbee goals, and we want to basically have that always aiming at the goal, so that who's ever controlling the robot with a controller doesn't actually have to like go back and forth and try to aim it really well, because that's hard to be precise with. So we have to get a latency down to under 30 milliseconds is kind of our goal, to be able to capture the image and then put it either on the camera or on the Jetson, do the computation, and then throw it to the robot brain and have it track it. Because anything larger than that, then it's kind of like jumpy as it's moving around, and it's not always, it's kind of lagging behind. And then a lot of it's just kind of finding the right combination of everything, right combination of camera, board, the image resolution, stuff like that. And if we want to do like image filtering and stuff before they get passed on to the model, because the goals are color coordinated, so one's blue, one's red. So kind of what we're gonna
Question, is using something like OIS an option for you guys, or does it have to be just a software side solution?
using,
For like the vibrations?
What is OIS?
yeah.
It's something object image stabilization. It's basically thing that the camera mount has that will handle vibrations better, basically.
I didn't know this thing, we could look into that, because it's mostly just on, I'm sure they're probably pretty cheap, but Sigbox would have to purchase them because they're for the robots. But yeah, I think they were looking into some civilization things. I don't know exactly, because Sigbox is more on the hardware side, that's what they're best at, so we're just leaving them to doing that. I'll make that suggestion though, because I didn't know there was just like these little things, because I thought it was either the camera system itself had to have something that stabilized it, or
Yeah, well, it's a like. If you-
is it its own camera, or is it something you attach onto a camera?
No, it's almost inertial thing that is on the lens itself, so the model. It has to have that by default. So if you have an attachment that you like a camera attachment, you will get one for OS very cheap, like it's there on all smartphones by default.
You can also get like stable cam platforms that are only used on phones, which you just plop the camera. It's like a platform that just moves around super smoothly. And I think if you like search up drone stable camera platform or something.
I wish I could show the video, because the video does have it like on a camera I don't know why it's not working. I tested it, but
If you want, we could leave the thing on. Give me 1 second, let's see if this works. Try that.
there we go. That's it on the robot moving around. So it's gotten pretty good in terms, you'll see it moving here in a second. Yeah, like that. So it's gotten pretty stable. It's not too bad. Before it was literally just like shaking so violently you couldn't tell, you couldn't see anything. So whatever they've done to do that, I don't know exactly what they've done, but it's pretty stable for now. But that's just the thing they want to improve upon.
You could also have you tried blurring the images of the kind that you catch and smearing them?
Yes, so that's another thing. That's the yeah, so that's our just testing a bunch of different, like testing between YOLO V7, V8, testing other ones. We haven't tested any other ones yet, but that's something we want to do. Resolutions, and then just blurring, flipping, all that kind of stuff, just to make it more robust, is all stuff we're looking into to try to just get higher accuracy. Yeah, and like I said, we want to test the onboard computation on the Oak One cameras versus taking that off and putting it onto a Jetson and then sending it over to the brain. Reducing latency, a big one was switching. We wanted to switch to YOLO V8, but YOLO V8 was like 2 or 3 times as long to do the putting a bounding box. Was it supposed to be slower? Is that why you say that, or no? I don't know. It was longer. I think it was just more stuff they have on the back end to try to get higher accuracy. That makes it a lot slower. And then we're pretty close to having it near where we want to in terms of just being able to put it on competition robot. And then from there, it's all just optimization. And once we get that, which should be within the next week or two after we get our data set, we want to start working on a general release to the public and then create more data sets of other items in the game. So like those little Frisbee discs. And then there's also like there's rollers that you could flip between blue and red, and those give you points in the game and stuff like that. So just making data sets for a bunch of things.
Okay, sorry, one more question. So the yeah, have you considered using or like tried using object tracking and interpolating that with like a hybrid approach with the bounding box to allow yourself more time? So if your read is significantly more accurate, you could just use object tracking for the data.
You had mentioned that, and that's like on the to-do list to
Okay.
check out is the object tracking. Because like I said, latency is the biggest thing. Like we can get super high accuracy if we do high resolution and then we just give it its time to do the computation. And so our big thing right now is like figuring out the trade-off between FPS and accuracy.
What's the frame time that you're looking at right now?
I feel like it's mid to high 30s if I remember correctly. What?
30 milliseconds.
Yeah, so we just want it to be like 25 to 30 milliseconds is like perfect. Like there's no visible lag when you're on the robot, like looking at the robot play the game. Right now you could definitely see it. It's like a little behind. But we have it aiming right at the middle of the goal. So even if it's tracking a little behind, it still should make it to the goal. It's just not as perfect as we would want. And then what was I feel like there's one more thing I wanted to mention. That's my last slide, right?
Yep.
Yeah. Working on the data set. We created the Oak One cameras have their own API. So we created just a script that'll run off the Oak One cameras, and we can onboard it, or plug it in the robot, and then just have the robot play the game by a person, how it normally would. And then we just capture a photo every 5 seconds. And then we're looking into like image labeling services, just get like a absolutely massive data set that can be from the point of view of the robot while playing the game. So it's like a really accurate POV. And then we also we want to throw that on the robots whenever they go compete in other competitions, because they do competitions almost every week all around the state and like around the Midwest. So we could just get a bunch of data sets, a bunch of different lighting settings and stuff, and that's a huge accuracy booster.
Okay, last question. You said that you were looking like in your general release, you were going to make it a framework rather than just like a model, right? So other than us, other teams and anyone can really use it. How do you plan on structuring that?
That's kind of to be determined yet, just because we haven't gotten the one model working up to where we want it. But mostly the bigger thing with releasing a computer vision model, because actual just running a computer vision on a camera is just kind of using weights and then running it through like a really simple Python script. So doing that's not the harder part. The harder part is getting the Vex brain to communicate with either a board or communicate with the camera and stuff. So that's more on the SIGBOT's team, because they develop the OS for the robots that like all the teams around the country use. So they actually have access to the source OS code, which helps them just make low-level things like that. So that'll be that's like 75% of that project. The other 25% is us we want to get a few data sets for different items that we can release to everyone, or have other teams, just help build a huge data set. And then also just be able to have anyone throw in any camera system they want, as long as you can convert it to like a NumPy array or something, which is what YOLO will accept. I don't know what else they accept, if anything. But as long as they can get their camera system to do that, we want it to be able to work, and then have whatever weights that they train. And then we want to develop a few like config files for the Oak One and the Intel RealSense and a few other cameras, just so teams don't have to do it if they're like widely used cameras. That it'll already be included in the framework. But
Question, is RL still anywhere in the pipeline? Is there any problems with training?
No, we don't. We stopped doing RL.
Cool.
Hey,
Sadly.
guys. Just please
well-
be mindful of time.
Yep.
Yeah, let's go to the next one.
Thank you.
Ivan, you wanna come?
Yeah, so,
Ready?
yeah. So our project was to, create a CNN that can detect, eye diseases from an image of an eye. Originally, we were trying to do that with images taken directly in front of an eye, but, we were running into a data issue where our data set just wasn't large enough. So now we've moved part of the team over to working with, retinal images, which are taken using, medical equipment. So it's obviously not as accessible to the average person. But we are trying to improve our data set for images taken directly in front of an eye.
Fine.
So our progress, so we've gone over the paper generative adversarial networks. We did the paper released by Ian Goodfellow in 2014. So that they understand, my team understands the basics of like what GANs are at this point. And that leads into why we're using GANs. As I said previously, we're missing a lot of data for images taken directly in front of the eye. So our idea was to train a GAN to or some sort of generator to generate images that would look like an image taken from directly in front of an eye. And so we've also been working. I forgot to write about this, but we're also talking about CNNs. So next week, what the team is going to be doing is we're going to be going to a Kaggle data set that has a bunch of retinal images, and we're going to be building a CNN that's we're trying to optimize the CNN for the Kaggle data set, and that's going to be an ongoing project. That's basically the main structure of our team so far. Another thing that we were kind of working on, this is basically halfway through the generation of an idea. So this idea is like nowhere near complete, but I thought it would be interesting to get some feedback right now. We've been talking about another type of generative network. I personally have not been able to find anything relating to this, at least on Google Scholar. So it may be a novel type of network, at least in the basic structure of it. But we can't say for sure whether it's novel because we haven't done enough literature review. So this is basically what the network looks like. You can see the generator square, right? It doesn't really matter, but so there's a generator that creates two sets of data. One set of data is inside of the class that we're training for. So for example, let's say we're trying to detect lilies and we have a class, and then the out class would be like just images that aren't lilies, right? So we would create one set of data and we would assign that to the lilies class, and we'd set one set of data and assign that to the out of the class. And the generator is basically at the beginning, it's basically generating noise, and it feeds that into a CNN. And the CNN basically runs through a couple of epochs trying to learn what a lily is, or from the noise that we've essentially fed it. And then we run it on test data. And obviously it's going to do terribly the first time it runs because we trained it on noise that has no relation to the actual test data. But the idea is we can look at that performance output, and then based off of the performance output, we can modify the way that the generator creates data. So basically the focus here is to create a generator that's able to generate data that can accurately teach the concept to a CNN. And because of that, we don't really want to get too focused on what the CNN is. So we're not going to be building what we're going to do is we're going to be using a backbone like YOLO or VGP16 because it's like tried and true. We know that the CNN is not going to be the bottleneck here. So basically, the idea behind this is that a lot of GAN, a lot of papers that go over the quality of the images created by a GAN, they talk about similarity scores like PSNR. And while there is a place for that, I think something that could also be a valuable metric is just how well it can teach the concept of what that image is, or what they're trying to generate images of to a CNN. And so instead of like using something like PSNR, at every step in the process, our generator is being evaluated for how well it teaches the concept essentially to a CNN. Obviously, there are issues when it comes to just like how efficient this is, because usually when you're training something like a CNN, you train it like a set amount of times, and then you run it on the test data. But what we need to do here is every single time we want to run our generator, and let's say we want to train our generator for like 30 epochs, we need to train the CNN for its amount of epochs for one epoch of the generator. Jeanette?
Yeah, what training do you guys use at the moment?
Hold on, one question before you answer. Let's just try to be a little respectful of time. We're going over. I'm
Oh,
gonna
okay.
set for like, aim
Sorry.
for like 5 more
if-
minutes.
Okay, yeah, if you guys are curious, we can just
Yeah.
talk to me after. I'll just move on to the
Cool.
next slide, I guess. So this talks about, basically, what we're going to, we're starting off with noise generation from the generator. So what we're going to do is essentially we're going to generate two original sets of noise, and we're going to see which set of noise by random chance is better at teaching the concept, and we'll kind of use that. We're not going to generate just two, but this is just for an example, and we're just going to see if we can walk towards the right answer. I say walk because, oh yeah,
That one?
next
Okay.
slide. Basically, what we're planning on doing is tying our noise generation to something like a scalar field, or maybe even a vector field. I said multiple scalar fields here, but that's just a vector field when we stack them into a vector. But what we're trying to do is we'll try to find the direction that optimizes the data, optimizes the output of the generator the best. And based off of that, we hope that eventually we'll be able to produce a complex enough output from the generator that we can somewhat teach the CNN the concept of the images that we're trying to create. This is definitely like still an idea in progress. So there are like rough patches, like we don't really know how we're going to tie this scalar field into idea generation, into the generation of the noise. And we don't even know if that's what we're going to go with as our final choice. This is just an alternative to using GANs. I guess the only other issue we're having is that we haven't had that many meetings yet because we just haven't. But from now on, we're gonna have like meetings basically every week. But yeah, this is definitely like a very in the rough idea. But if anyone wants to ask me more questions about this after the meeting, that would be cool.
Fine, awesome. Okay, time series. Talk about. Right.
Hello, everyone. My name is Vamsi. I don't think anyone here knows who I am. So, that's
Yeah.
great. Anyway, nice to meet you guys. Unfortunately, Samia isn't able to make it today, so I'll be delivering our project updates. Okay, so about our project, we're a team of 6 people, and we're basically working on building time series forecasting models to predict pollution levels in any area. So our project currently, we've picked California, and we're studying LA in particular. California is the most polluted state in the United States, so of course there's a lot of data for it. And whatever conclusions we come up with and whatever models we make, it's something that can be generalized to any state in particular if you want to. The website we use for our data contains information for about every single state, so we're good in that regards. As for our goals, our first goal is to develop accurate forecasting models for PM10. Just so you know, PM10 is one form of pollution. There are a lot of other types like carbon dioxide, sulfur dioxide. I think there's a PM 2.5. Yeah, so we just picked PM10, just to try whatever models we want to work on. So we want to develop accurate forecasting models for finding out the most polluted areas in California, and also to predict the pollution levels. So far we built an LSTM model and an ARIMA model. The ARIMA model is something we worked on last semester, and the LSTM model is something we've been working on this semester. More on that soon. The next goal of ours is to identify key areas that are causing high levels of PM10 in California through statistical analysis. So of course, there's a lot of data that we have regarding the pollution in every state, and so we want to employ some kind of data analysis techniques and see what we can conclude from these data. And our final goal is basically an extension of the first one. We want to see We want to see if we can build more models apart from the one we've done already and compare their performances. Next slide, please.
Sure.
Okay, so as for the model, so this semester we basically spend most of our time learning how an LSTM model works. We built a basic model that, well, just recently we got it to work, and this is just one of the evaluations we did recently. There does seem to be some issues in it. We haven't found any bugs as of yet. It's something we're going to be working on right now. Also, we have Caitlin who's working on trying to understand the correlation between the weather patterns in the state and the pollution levels and see what we can conclude from that. As for issues, we haven't had any particular issues apart from what we're working on really. The model itself seems to work for now, but it does have some issues that we saw from the graph before. Can you show the full change, please? So as you can see, the graph itself, like the predicted values, it does seem to be like shifted one day forward. And when you shift it back one day, it does seem to be sufficiently similar. So right now there does seem to be some kind of overfitting going on. We're not sure yet, it's something we're working on right now. But apart from that, we haven't had any real hurdles or issues. Next one.
Sure.
So what are our next steps? So as I said before, we need to fine tune our models, find out what's going wrong, and see if we can fix them. As I've already told you, we're also working on doing some data analysis, trying to find out what we can for the data that we have, and that would be something great if we can do it soon. Also, another thing we're trying to do is we're trying to make a web application to deploy our model. We're using a library called Streamlit. It's basically a library that allows you to create an application to showcase any kind of data science project that we have. I myself never heard of it before. I only heard it the first time and she mentioned it last week. So it's something that we're learning as we're doing. Yeah, that's it. That's all we have. Thank you.
Alexi? One question.
Oh, yeah. Have you guys looked into any area outside of California? This is just for me. Meaning like there's a lot of different areas, thinking up north, it's a lot less polluted compared to down in LA or even San Diego, right? Do you guys think that's a variety or just purely LA?
I mean, we just picked LA as an example because it's like the region with the most pollution in California.
Yeah.
And also we did get data for like the last 3 years of pollution in LA. So that's what we're working on right now.
Okay, it's probably the best quality data too, right?
Yeah.
Cool, just curious. Right, go ahead, Alexi.
Hello, I'm Alexi. I am doing the EA Hub with Sarah and Stanley with Team Connectivity. Slide. So the goal of this project is 2 parts. One, we need to identify external. So the whole point of this is that TE has provided us with a bunch of data for different of their financial data for different products that they sell. And our goal is to develop models that could effectively predict each different product. And this is 2 parts. One is actually creating an accurate model for generating 18-month rolling predictions with 80% accuracy. And 2 is finding other external features such as stock price and then other financial data related to the actual products that are sold. Next slide. So project progress today. This right now is the sequence model, as you can see. First of all, right now we're still like effectively debugging and seeing how to improve it. So currently it's only using 50 epochs and like the architecture extreme low levels, like 100K parameters. And again, like it's only trained on a few, and as you can see, like this is how the results are. So green is the error that's happening, orange is the actual, and blue is the actual prediction, and this is like leaked the test data, so it has not seen it. So in reality, we will be able to access the orange data, but like we're making the task slightly harder. Additionally, actually, we're supposed to predict 18 months, but we are actually, which is 18 times 7. But here we're predicting around 78 times 7. So effectively, we are creating a far more accurate model that's predicting on a week by week basis instead of a month by month basis. Okay, additionally, this is the actual framework for actually how to analyze external data factors. So every single blue line, that is a different product parameter. And in this case, we are comparing the high trading stock data to other products. And again, for every single one, it computes the accuracy, the bias present, and bias is like basically like whether it unpredicts, over predicts. It also computes the standard error. And again, like it just also computes overall accuracy. So for next week, one of our largest tasks is to effectively take this. And we found out data set with like 170 different parameters and basically run it through it and get the parameters with the highest accuracy and then actually take a look like whether these parameters make sense. Yes, that's on this slide.
Cool.
Let's see. So next goals, right now, I'm extremely suffering. The time transformer is being extremely painful, but there is a lot of hope that it might actually work. Second of all, it's actually we need to try out the model with the different external features that we have found and train it up. But like random architecture is extremely modular, so you can probably just like add another input data column and it will be able to use that input in its prediction. And finally, it's actually to like effectively actually use all the data with a large enough architecture to actually see like effectively do like a whole run using all the data, all the architecture, and all the augmentation.
Awesome.
Cool. Yes.
Good to go.
Yes.
Cool. Grant, you'll come. I can slides, whatever you want.
Cool, yeah. So, hey everyone, I'm the PM for algo trading.
You want me to go?
Yeah, good to go. Just a quick recap of the project. The purpose of our team is really to teach people to how to develop high-performing trading algorithms, as well as prepare for competitions hosted by some big companies in the industry and prepare for interviews at quant firms. So we started off the semester by giving an onboarding project to our new members. And the purpose of this was really to get them familiar with using the Quant Connect trading engine. And so this is a pretty popular tool. It's really helpful for backtesting algorithms, meaning testing them in the past as if you had been running it like for a certain time period and seeing the performance. It also has a pretty useful API and a lot of data from various markets to help you test your algorithms. And so we did that. Everyone made pretty basic algorithms using more traditional indicators like moving averages, MACD, that sort of thing, just to get familiar with using the API. Then we started going into something called pairs trading. And so this is a more traditional quantitative strategy. And for those of you who aren't familiar, pairs trading is basically, instead of looking at the price of individual stocks, you're looking at the relationship between two stocks. And so let's say you have stocks like Coca-Cola and Pepsi. They're very similar companies, and so they have a strong economic link. And so you look at the ratio of those prices. So this is an example, and you can see the ratio of those two stocks is actually mean reverting. And so historically, it always hovers around some mean value. And you can expect that in the future, it will continue to hover around that value because of the strong economic ties that those companies have. And so the benefit of using this strategy is you can really isolate your insights from market conditions, because it's actually possible that the market could have a big downturn and you still come out ahead because your only bet is on the relationship between the two companies you've looked at and not necessarily on the overall market. And so if the relationship holds up, then you can actually make money regardless of overall market conditions. And so we looked at the two components of designing a pairs trading algorithm. The first one is actually selecting the pairs that you want to trade. And so for starters, we're just using stocks, but this could really be any tradable asset that's highly liquid. You could use Forex, you could use crypto, basically anything that's traded on an exchange and is liquid. And for this, what you really want to do is verify that the companies actually have a strong relationship that will continue into the future. And so you wouldn't want a relationship to just have held up for the past few years. You would want it to hold up even in times of volatility, right? So that way you can rely on it to continue going for the near future. And as well as that, you don't just want to look at common pairs like in the S&P 500. Like Coke and Pepsi is a very popular example for beginners. But at the same time, because everybody is so aware of it, it's also a highly saturated strategy to use. So you want to find a way to discover new pairs that aren't necessarily known by many traders, and that will give you better performance. And so the one popular way of doing this is with co-integration testing. And so this is a way to actually check that two stocks have their price ratio reverts back to a historical mean value. And we're also looking at different ways of clustering. And so this can be helpful, especially if you have a more detailed data set that doesn't just use like a price or returns and actually discover pairs that way. And that's really what we want to work towards, because as you can imagine, if you're just randomly checking hundreds of different pairs from something like the S&P 500, you're going to get false positives in there if you're just using a simple co-integration test. So we're starting with that because it's easier from a beginner standpoint, just to get something up and running. But later on, we definitely want to move towards looking at different clustering algorithms. I think Optic is a pretty popular recent one. And it's used by a lot of new pairs trading algorithms. So that's definitely something we want to look into. What else? Yeah, and then so basically the approach for this is to split into 3 teams. Everyone is working on a pairs trading algorithm for each team. But the reason for doing this is because we have about 15 to 20 people who are actively contributing to this. And so in reality, you can't really have 20 people just working on one algorithm because there's not enough work to go around. So we split up into 3 teams, and then we're going to work on it for a while and then come back at the end and compare results, compare strategies and all that stuff.
One question.
Yeah.
What's like a very well-known pairs, it's like a strong trading pair that isn't intuitive, but like everyone that's in the industry kind of knows? Do you have any like strong example of that?
Off the top of my head, I don't. I know that you can look at things like index funds versus individual stocks. So Nvidia and NASDAQ is a pretty strong one.
Yeah.
But that's like comparing a whole basket of stocks to just one stock.
Yeah.
Yeah, off the top of my head, I can't think of any that are like not immediately obvious.
Okay, sure. Yeah.
So when you're doing this, are you using options or are you just investing in?
Yeah, so you can use anything that's highly liquid or liquid enough based on, like, if your algorithm is looking at highly related stocks on a monthly level versus like a yearly level, anything that has enough liquidity to support that type of strategy. So Forex, crypto, like I mentioned, you could use futures and options. You could have like one stock and then an option contract for that stock or something. So it really just depends on the data that you have and then what you find with that.
Cool.
Yeah, no blockers. We just started with this last week, so most teams have only had 1 meeting so far. We'll probably have some issues later because a lot of the teams are very beginner heavy. And so I'm going to set up like weekly progress checks with each team just to make sure that all is going well. But so far, we don't have any issues with that. So next steps, like I mentioned, just continue working on the pairs trading algorithms, finding better ways to select pairs rather than just like running hundreds of co-integration tests on an S&P 500 index fund or another index fund. And then there are also 2 competitions coming up in March. And so these are both beginner friendly. And this is going to be a great way for some of the newer members to get experience. I think it's the Optiver competition, and IMC is also hosting one in March. And so that'll be interesting to see how we do there. And by the way, they're like, I think they're both pretty much you apply for it and they accept you. So if you're interested in participating in one of those, the applications are still open. So talk to me if you want to look into that. And then also what we aim to do is after we're done with the pairs trading algorithms, live test them using Quant Connect. So this will be interesting because rather than back testing it historically, we're going to see how it would actually do in the present. And we'll probably run that for maybe a few weeks or even a month while we work on something else and then go back and look at how each team performed.
Cool.
Yeah, that's pretty much it.
Okay, awesome. All right, Kaggle, Neil, go on.
Hi guys, I'm Neil and I will PM. I'm gonna keep this short. Yeah. All right, so Kaggle is where you can do data science competitions and come with models and submit them for testing that how well your model was, how accurate it was, and what happened if your model was really good. So given that it's a beginner focused project, we had some new members and we're doing member onboarding and introducing them to the team and how it works. One of the main ways that we did this is through the past 2 weeks, I've been brushing up my skills and brushing up my team skills on learning machine learning courses on Kaggle. It goes pretty in depth with pandas, models that you can use, CNNs, etc. And this will help us when we need to have different implementations for certain competitions. Like I said, we've been so far, like what we've been recently learning is overfitting, underfitting, and mixed regression reports.
Okay.
And so issues that we have is transitioning from what we learned and giving everyone a role to have when making a model. So I myself do not have as much experience with distributing this work, so we're gonna have, so if anyone would like to give me some feedback on how I can help make sure that all people have an equal amount of opportunity to learn and implement what they've learned into a role. And please let me know. Another thing is kind of availability. We haven't had that many meetings yet, but we're looking to ramp up meetings and then increase how quickly we go through the courses. So currently, we want to get through at least the deep learning course as well. Before we start doing some of the other competitions besides the basic ones, such as regression. Yeah, no, like I said, we don't have any meetings yet, and we're looking to go a little bit further into deep learning courses and how to validate our models that we've made so far. And then submitting a model to a competition by the first of March using all the skills that we've learned so far.
Okay,
That's all I had. Thank you guys.
cool. And with that, we conclude stand-up, I believe. Is there any questions anyone wanted to ask or do a little roundtable? We can do that right now. So yeah, any questions you guys have for me, officers, Jacob? All here. No? Okay, I believe, is there stand-up for a team right now, like 7:30? Do you,
Sorry.
there should be a stand-up in about like 10 minutes, right, for one of the teams? I think it's chatbots. Do you-
Yeah, that's why I started now.
Okay, cool, but everyone else, I think we are good to go. Thanks for coming. Cool. Hey Ian, thanks for coming. You have any questions? Yes, not. Okay.